Have you ever heard of the popular casino game Blackjack? If not, stay tuned, because in this video we will be going over the rules of Blackjack and breaking down the probability of the game. Blackjack, sometimes called 21, is a casino game where players play against a dealer to get cards that sum to as close to 21 as possible without going over. First, let's talk about the value of each card. The number cards, 2 through 10, are equal to the face value of the card. Face cards, like Jack, Queen, and King, all have a value of 10, and aces can have a value of either 1 or 11. The rules are simple. Everyone places a bet on the table. After bets are placed, the dealer will deal everyone one card face up, including themselves. After the first round of cards is dealt, each player is given a second card, face up, and the dealer takes the second card but keeps theirs face down. After all the players have their two face-up cards, they can see how close they are to 21. If a player has an ace and another card with a value of 10, they have what is called a natural blackjack, and they win automatically, as long as the dealer doesn't also have a natural blackjack. If a player doesn't have a natural blackjack, they can make one of two moves. Starting with the player on the left and moving right, a player can stand, where they stop receiving cards, or hit, where they receive another card. If a player hits and goes over 21, the player busts and loses the round. If they hit and do not go over 21, they can continue to hit or choose to stand. When one player busts or stands, the play moves to the next player. Once all the players are at stand or have busted, the dealer plays. The dealer will first turn over their face-down card. If the total is 17 or more, the dealer must stand. If the total is 16 or less, they must take a card. The dealer must keep taking cards until their total is 17 or more. Once the dealer stands or busts, any player closer to 21, then the dealer wins the round, and anyone farther loses the round. There are a few more nuanced rules, but for the sake of today's video, this is what we need to know. When we look at blackjack from a mathematical perspective, it really is a game of probability. And because of this, we can calculate the likelihood of winning a game of blackjack over various scenarios. The first thing we need to do to understand the probabilities of blackjack is to determine the sample space of the data. A sample space is the set of all possible outcomes in an experiment and is typically denoted by S. In the case of blackjack, and for the purpose of this video, we will make our sample space the possible initial two-card combinations which can be created on the initial deal. We will stick with a simple 52 deck group, but it should be noted that in casinos, dealers typically deal from more than one deck. Most commonly, they use 6. To determine the number of possible two-card combinations, we use this combination equation, in which n is the total number of objects, and r is the number of objects in an outcome. This equation is used when the order of the chosen objects does not matter, and there are no repeats of an object, which is a reasonable assumption in the case of blackjack. Using this equation with an n of 52 for the 52 cards in a deck, and an r of 2 for the 2 cards dealt to the players, we see that there are 1,326 possible combinations at the beginning of the game, which we'll refer to as points and use to define our sample space. With the points within the sample space now defined, we can determine the probability of specific events. Events are subsets within the sample space in which a defined criteria is met. For example, we can define event E as outcomes where you get a natural blackjack, or an ace and a 10 value card. The probability of these events can be determined by the dividend of the number of points that fall within the event divided by the total number of points in the sample space. With these events, we can determine the probabilities of getting different starting values in your two card combinations. Let's start by calculating the probability of getting a natural blackjack at the beginning of the game. First, we must determine the number of points in the sample space which satisfy the event of a natural blackjack. In a deck of cards, we know there are 4 aces, and for the 10 value cards, because 10s, jacks, queens, and kings can all equal 10, we have 16 possible 10 value cards that can be in an outcome. So, if the combination of any of the 4 ace cards with any of the 16 10 value cards is a natural blackjack, we can determine the number of combinations by multiplying the number of aces with the number of 10 value cards, giving us 64 points, which satisfy our event. So, to get the probability of a natural blackjack, we can divide the 64 points in the event by the 1,326 points in the sample space to give us a probability of approximately 4.8%. We can also do this for other two-card sums. For example, if we want to calculate the probability of the first 2 cards you receive summing to 20, we can follow the same process. We first need to see how many of our points satisfy the event of a sum of 20. To do this, we need to determine the number of combinations that sum to 20. The two ways which you could sum to 20 is with an ace and a 9, or with two 10-value cards. We can use the equations from earlier to determine the number of two card combinations we can get from the 10-value cards. With 16 10-value cards and a group size of 2, there are 120 possible combinations. For the ace and 9 combinations, we can also determine the number of combinations by multiplying the number of one group with the number of the other. So 4 aces multiplied by 4 nines gives us 16 possible combinations. 120 plus 16 gives us 136 points within the event. 136 divided by the total points in the event space gives us the probability of approximately 10.3%. This means you are around 2 times more likely to get 20 in your first two cards than you are to get a natural blackjack. After the first round of cards are dealt, we can determine the probabilities of getting closer to 21 or busting under conditional probability, or the probability of an outcome after some event has already taken place. Once all the first two card sets are on the table, we can shift focus from the probability of two card combinations to the probability of getting a useful card if you hit for more cards. Let's say you are player 1 in a game with two other players. After the first set of cards is dealt, the number of cards in the deck decreases from 52 to 44 cards, giving us a sample space of 44 points. Now, if we say you got a sum of 13 in your first two cards, you may be tempted to hit. So let's calculate the probability you bust on the next card and the probability that you hit 21 on the next card. Let's start with the probability of hitting 21 on your next card. In order to hit 21, you need an 8. If we consider the ideal condition in which no 8s have entered the table, then the deck should have 4 8s remaining, or 4 points, so we can calculate the probability as the 4 points of the event of an 8 divided by the 44 points in the total sample space, giving an approximate 9.1% chance of hitting 21 on the third card. This is an ideal case in which no one at the table, including yourself, has been dealt an 8 yet. In the event that there's an 8 already in play on the table, then the probability of getting a 21 decreases about 2.3% for every 8 in play. We can apply the same principles to determine the probability that a third card would cause you to bust. If any of the cards bigger than 8 are dealt, then you would bust, which means a 9, 10, jack, queen, or king would cause you to bust. Note, an ace will not cause you to bust because it can be counted as a 1. Once again accounting for the ideal condition where none of these cards are on the table, there are 20 cards in the deck which would cause you to bust. Those 20 points divided by the 44-point sample space gives about a 45.4% chance of busting on the next card. This chance of busting also decreases by 2.3% per the number of card in the event which has already been played on the table. From our calculations, we can conclude you have a 4.8% chance of a natural blackjack in the initial 2-card deal. You are 2 times more likely to get a sum of 20 in the first 2-card deal than a 21. And you are 5 times more likely to bust on 13 than you are to get a natural blackjack. Now you know how to calculate some of the probabilities associated with winning the game blackjack. But remember, always gamble responsibly. Can you calculate the probabilities for some of the other combinations? Let us know which one is the most likely to occur in the comments below. And while you're down there, let us know if you want to see more content like this. To be notified when we make other videos, subscribe. And don't forget to check the link in the description to check out some of our other resources.